Hi, and welcome to the Graph for Near Learning Pathway by Figment. My name's Aaron, and I'm going to be your teacher slash guide for this learning journey as I teach you how to build subgraphs for near on the graph. So prior to starting this learning pathway, it's highly recommended that you complete both the near and the graph pathways. They're not absolutely required, but you'll probably find the background useful as you move through these lessons here. Also in this pathway, you're going to find reference to a ceramic network. There's also a learning pathway for that, and something called decentralized identifiers, or DIDs. The near contract that we're going to use in this pathway is a DID registry contract, which basically associates a near account with a decentralized identifier, which then allows us to query the subgraph that we're going to build, pull this information, the DID information in, and then pull in some more information from the ceramic network. That's not necessary to understand for this. We're mostly focused on building the subgraphs, but just in case you see those terms come up, now you know what they are. So if you're already familiar with the graph, near and ceramic, and you're just ready to get started, then feel free to skip the rest of this lesson here and get right into the coding. But if you want to read more about the graph, near protocol, there's some resources curated down here below that you can take a look at and go from there. I will give you just a quick overview of what the graph is. It's sometimes referred to as the Google of blockchains. So like Google indexes search results, the graph enables indexing of blockchain data. So that makes it possible to use the data that's stored on blockchains in ways that are usually difficult or impossible to do if you're directly asking the chain for the data itself. For instance, many developers will build some kind of GET query into their smart contract to return a specific type of information, like a token balance or the owner of an NFT or something to that effect. But anything that's more complex, where you're trying to aggregate data or do complex queries on that data, is pretty much impossible to do by looking directly at the chain. You need an indexer that pulls that data off the chain, puts it in a database that you can then query against. And that's kind of what the graph does for us. But the good thing about the graph is that it stores that data in a decentralized network, so you don't lose that decentralization bit. If you look at any kind of production type application, blockchain application, a blockchain explorer, for example, it's probably 100% most likely going to have an indexer on the front end of it or attached to it, pulling the data off that is actually feeding that application. Otherwise, you're going to get significant lag trying to pull it off the blockchain itself. So indexing is a hard thing to solve, and the graph has kind of done that bit for us. So instead of you having to stand up your own indexer to index the chain for your data, the graph provides an effective way to make that indexing and querying relatively simple, and importantly, as I mentioned, does it in a decentralized manner. Unfortunately, with near, currently the decentralized network is not available, but the graph does have a hosted service, which we'll be using in this learning pathway, and we'll learn about here in a bit. But it provides a way to put the subgraph up and then query it. It is a centralized one point of failure kind of indexer at the moment, but when the hosted service or when the graph network achieves feature parity across everything, then they intend to shut down the hosted service and move things over. So at some point it will be possible to run a local graph node on near. It's just at the moment it's pretty complex and not documented as to how to set that up. So we're not going to do that. In terms of how the graph works specifically, an application will interact with a chain. The subgraph that you're going to build is basically listening to the chain for, in the case of Ethereum, events, in the case of near, for things like blocks and receipts. And then every time it sees that, it's going to pull the data off, send it to a graph node, which stores it in their database, decentralized or not, and then your application queries through GraphQL, those databases, in order to get the data they need. So that's just a general overview of the graph, and that's it for now. So happy to have you here. Looking forward to getting you building subgraphs for near on the graph, and it's going to happen in very short order. And I'll see you in the next lesson.